Hello all. In the previous video, I talked about the polymerization based on the mechanisms of free radical. I talked about free radical polymerization. So in this video, I am going to talk about the ionic polymerization and coordination polymerization. So let's see what is happening in the ionic polymerization. So in free radical polymerization, initiation, propagation, termination steps was brought about by free radical. But in case of ionic polymerization, this is brought about by negative and positive ions. So based on these ions, this polymerization is divided into two types, cationic polymerization and anionic polymerization. So we can discuss about cationic polymerization. So in cationic polymerization, when a proton is introduced into a monomer, this proton pulls the pi electron pair towards it from the monomer and its positive charge is transferred to the farther end of the monomer and thus forms the carbonium ion. And this carbonium ion initiates the chain growth. Normally, the monomer which have electron donating groups attached to the double bond will form carbonium ions. Example for it is propylene, styrene, isobutylene. So let's see how it initiates and propagates the chain growths. First initiation. Here this proton reacts with monomer, first monomer. What happens is that this protons attracts this pi electron from the monomer towards it and transfer this positive ion towards the farther end of the molecules like this and forms a carbonium ion like this. This carbonium ion initiates the chain growth of the polymer. So next is the propagation. So the carbonium ion formed at the first monomer unit reacts with the fresh monomer. Here also the same process is happening and thereby forms a polymer chain, and this process will goes on further and the chain growth will increases. I already told you that the ions, positive or negative ions, will participate in the ionic polymerization to initiate the chain growth. So next we can see how these ion pairs occur to form a carbonium ions in the monomer. For example, Lewis acid such as BF3, which is used in the ionic polymerization as a catalyst. When this BF3 reacts with a co-catalyst called water, as a result it forms the hydrates. This will act as a ion pairs. Let's see how. This BF3 reacts with the water, we will get the hydrates. It contains a counter ion and the proton. And this proton H plus is the initiator and F3BOH is the counter ion. This proton H plus ions will attack the pi electron pair of the monomer and initiate the chain growth. Let's see. This is a hydrate. This hydrate, when react with this monomer, the pi electrons in the double bond, the pi electrons will attract towards the proton and its positive charges goes to the farther end of the monomer like this. So the pi electrons are moving opposite to the direction of the chain growth. That is, these pi electrons are moving towards here and the chain growth is increasing. So its pi electrons are moving opposite to the direction of the chain growth along with the counter ion. So this chain growth is going along with the counter ion. So next step is the propagation. In propagation, the chain growth is increasing. That is, the carbonium ions formed in the first monomer reacts with the second monomer and the reaction goes on further like this. So the chain growth is increasing by forming a carbonium ions along with the counter ion. So next step is the propagation. In propagation, the chain growth is increasing. That is, the carbonium ions formed in the first monomer reacts with the second monomer and the reaction goes on further like this. So the chain growth is increasing by forming a carbonium ions along with the counter ion. So in cationic polymerization, pi electrons are always attracted towards the direction opposite to the chain growth, and the carbonium ions are moving in the direction of the growing chain along with the counter ion. So next is the termination. Terminations is happened by colliding these carbonium ions and counter ion of the another growing chain. That is, when the initiation happens, there may be a formation of multiple growing chains. So uh, while in the case of terminations, this carbonium ion will react with the counter ion of another growing chain, thereby the termination will occur. So based on this, there are two types of termination. One is ion pair precipitation and second is a termination by coupling. First we can see about the ion pair precipitation. This can be done by donating this proton to the counter ion and forms a double bond in the growing chain and thus chain growth stops. Let's see how it happens. So in ion pair precipitation, this carbonium ion formed in the polymer chain will react with the counter ion of the another growing chain. So in initiation, there may be a chance to form a multiple growing chain. So the carbonium ion of one growing chain will react with the counter ion of the another growing chain, thereby chain growth will stop. So here we can say that this is a growing chain containing carbonium ion and a counter ion. So when this termination occurs, what happens is that this carbonium ion, that is this H plus ion, will transfer towards the counter ion and forms a double bond in the polymer chain. Thereby the chain growth will stop. This is known as the ion pair precipitation. And next is the termination by coupling. When two growing chains couples, the C plus ions of the growing chain collide with counter ions of another growing chain. As a result, a covalent bond will form between C plus ions and the counter ion, and thereby chain growth is arrested. Let's see how it happens. So next is a termination by coupling. This is a growing chain with a carbonium ion and a counter ion. When this carbonium ion and counter ion couples each other, as a result, there forms a covalent bond between the counter ion and the carbonium ion. Thereby the chain growth will stop. So in cationic polymerization, initiation is done by the proton and the propagation is done by the carbonium ions. Example for initiators are BF3. I already told with the example. Next, another one is AlCl3, aluminum trichloride, SnCl4, TiCl4. These are the initiators that are commonly used in the cationic polymerization. Next is the anionic polymerization. So, in this anionic polymerization, the pi electron pair of the monomer is attracted by negatively charged ion, that is known as anion. So, when it attracts the pi electron pair of the monomer, it actually pushes the pi electron pair to the end of the molecule and forms a carbonium ion. So, normally the monomer containing electron attracting substituents will form this carbanion to initiate the polymer chain growth. Example for it is butadiene, isoprene, styrene, acrylonitrile. Let's see how this initiation can be done. So this anion, when this anion reacts with the monomer, this anion attracts the pi electron pair of this monomer and it pushes the pi electron towards the end of the monomer. Thereby forms the carbanion like this, and also this will form a sigma bond between this monomer. Okay, this is known as the anionic polymerization, and this carbanion will initiate the chain growth. Thereby propagation also can be done. So next is propagation, that is the carbanion forms in the first monomer unit, now propagates the chain growth. This is the first monomer unit forms the carbanion that reacts with the second fresh monomer. So the same process is happening here, thereby forms a polymer chain, and this process continues and forms a polymer chain and thereby increases the chain growth. So in anionic polymerization, the movement of electron pair and forms carbanion is in the same direction of the growing chain along with counterion. But in the case of cationic polymerization, the movement of electron pairs are opposite to the chain growth. But here this carbanion is in the same direction of the growing chain. Example for initiators are butyl lithium, triphenyl methyl potassium, ethyl sodium. Next, we can discuss about the termination in the anionic polymerization. In anionic polymerization, termination will not occur unless if some impurities are present in it or by adding ionic substance deliberately into it. So, in this case, carbanion at the chain ends are always active. So, that is, it is capable for initiating the chain growth again. So, it is always active. In anionic polymerization, polymer formed are always active. So, it is said to be living polymers. So, that is all about ionic polymerization. Next, we can discuss about the polymerization based on coordination mechanism. So, based on coordination mechanism, polymerization is said to be a coordination polymerization. Normally, olefins and dienes monomers undergo this coordination polymerization. In this process, what is happening is that this organometallic catalyst, when reacts with diene monomer, we will get a monomer metal complex. So, a complex structure will get. So, there will be a formation of bond between this metal ion and the carbon atom of the monomer. So, this is the active center which will initiate the polymer chain growth. This monomer metal complex will initiate the chain growth of the polymer. So, this is the monomer catalyst complex which will initiate the polymer chain growth. So, this is the propagation steps. Let's see how it happens. So, the bond between this metal ion and this carbon atom of the monomer is the active center which will add this monomer into it. So, this monomer is actually inserting between this metal ion and the carbon atom of the monomer. So, it is inserting. So, this coordination polymerization is also said to be insertion polymerization. Because this monomer is inserting between this metal ion and the carbon atom of the monomer. Thereby, we will get a polymer chain, and this process will further goes on, and thereby the propagation happens and the chain growth is increasing like this. So another important factor is that this catalyst monomer complex formed a heterogeneous system because metal ion is in the solid phase and the carbanion of the alkyl group is in solvent phase. So when this organometallic catalyst reacts with the monomer, thereby it forms a carbanion in the monomer. That's carbanion of the alkyl group is solvent phase and the metal ion is in solid phase. So because of that there will be some polarity. So, and this polarity will lead to some spatial arrangement between metal counterion and the anion. This spatial arrangement will result stereo regularity into the polymer chain. So normally to impart the stereo regularity into the polymer in coordination polymerization, normally catalysts used are Ziegler-Natta catalyst. So next, what is Ziegler-Natta catalyst? It is a mixture of catalyst and a co-catalyst. Catalysts are halides of group 4 and 8 between 4 and grade 8. So example for it is alkyl aluminum compounds such as triethyl aluminum or diethyl aluminum chloride, and co-catalysts used are titanium chloride. So these are the catalyst and co-catalysts used for making this Ziegler-Natta catalyst, and that is used for the um, formation of this coordination polymerization. So this is the structure of the Ziegler-Natta catalyst. And this aluminum is the electron acceptor and the titanium is the electron donor. So when this catalyst and co-catalyst mixed together to form Ziegler-Natta catalyst, there forms a chemisorption, means chemical adsorption. The chemical adsorption of the aluminum by this titanium, thereby the Ziegler-Natta catalyst will forms. So as a result of this chemisorption, the electron deficient bridge complex will forms, and this titanium, this part is the active center, which will reacts with the monomer, or which will insert the monomer into this complex structure and thereby propagates the chain growth. So let's see the initiation steps. So this is a Ziegler-Natta catalyst. When it reacts with the monomer, the bond between the Ti and this R will open and the monomer is inserted into it, and thereby forms the electron deficient titanium and the carbanion at the R. This initiates the chain growth at metal carbon bond, which regulating the active center. In this way, the initiation steps starts. So repeat this process and add the second monomer to this structure, and thereby the chain growth will increases. But here we can see some stereo regularity, some special arrangements are there. So it imparts some stereo regularity into the polymer while using the Ziegler-Natta catalyst in this coordination polymerization. This is the propagation steps, and in this way the polymer chain growth is increasing. So these are the 3 steps of the coordination polymerization. Just to know, we can written like this. This is the metal ion and the carbanion of the metal monomer complex structure. So in the initiation steps, this is the active center. And when it reacts with the monomer, this monomer will inserted between this metal ion and the carbanion, and thereby initiates the polymer chain. What is actually happening is that this metal ion attracts the pi electron pair of the monomer, and this counter ion will attract the electron deficient center of the monomer. This metal ion attracts the double bond, and this carbanion will attracts the electron deficient center of the monomer, thereby initiates the polymer chain. And at the propagation, this will react with this fresh monomer, and thereby the increases the polymer chain growth. Next we can discuss about the termination. So there are 3 types of termination in coordination polymerization. First is termination by active hydrogen compound. This is similar to the chain transfer mechanism. That is, this is the growing chain. When it reacts with this, what happens is that this hydrogen is abstracted towards the growing chain, and thereby the chain growth will stop. This is a termination by hydrogen compound. Next is termination by transfer with monomer. That is, the growing chain when it reacts with the monomer, the hydrogen from the monomer is attracted towards the growing chain, and thereby the chain growth will stops. Next is the termination by spontaneous internal transfer. Let's see how it happens. Next is the termination by spontaneous internal transfer. So the polymer chain formed, there is an internal transfer will happen in the polymer chain, that is here. This is a growing chain, and what happens is that this metal ion will abstract the hydrogen from here, and thereby forms a double bond here, thereby chain growth will stops. So this is all about today. Today we discussed about the ionic polymerization and different type of ionic polymerization, and also we discussed about the coordination polymerization. Okay, in the next video I will discuss about the condensation polymerization, and the polymerization techniques like bulk polymerization, suspension polymerization, and emulsion polymerization. Okay, today we are concluding by a coordination polymerization. Thank you.